This is 4.4 Student Notes, Mathematical Models, Day 2. Naturalists find that the population of some kinds of predatory animals vary periodically. The population of coyotes was tracked for several years in Colorado, starting at time t equals 0 years. Records indicate that minimum numbers, 200 coyotes, occurred at time equals 2.9 years. The next maximum at 800 coyotes occurred at 5.9 years. Okay, so I'm going to underline some of these important things. So the first thing it says is to sketch a graph for this sinusoid. That would be the first thing that I would do every single time. So let's go ahead and graph this, making sure that you label your axes, because that's something that I will count off if you don't label. So I'm going to label my x-axis in time for years, and let's do our y-axis for the population for the number of coyotes. Okay, so the first thing it said is that we know at 2.9 years, we know that there's 200 coyotes. So that's where I'm going to start. 2.9 is 200 coyotes. 5.9, we know there's 800 coyotes. So let's skip over a little bit. 5.9, there's 800 coyotes. And that's about all we know. So we can go ahead and finish this. So this is a difference of 3, add another difference of 3, and that's going to give us 8.9. So that's got to be another minimum. So we can do an inverse cosine. We can find our sinusoidal axis right here. That's going to be at 500. That's going to help us out. And again, you don't have to list these points unless you're just dying to find them, which I am not going to. That should be good enough for our axes or our graph. So let's go ahead and find our equation. B says to write an equation. So let's see. The population would be equal to a shift up of 500. And I'm going to go ahead and do a positive cosine graph, so that would be plus 300 cosine. Need to find our b, and this is going to be t, and since I'm shifting over to 5.9 because I want it to be positive, just to make it easier. You could start at 2.9 or 8.9. Okay, our period right here is going to be 6, so that's going to be 2 pi over 6, which reduces to pi over 3. Okay, so this is B, our equation. Now C says predict the number of population when t equals 7 years. Okay, so let's go to our calculator now. To y equals, and let's plug in our equation. This is going to be 500 plus 300 cosine pi divided by 3 and x minus 5.9, and close our parentheses. So let's go to our startup, and I've already got it on ask, so we can go to our table. See, my answer should be 600, which doesn't make 622.02 coyotes. So let's just round that to a whole number so that we've got 622 coyotes. Okay, for D, it says coyotes are declared to be endangered species when their population drops below 300. Between what two non-negative values of t were coyotes first endangered? Okay, so basically we're going to go to our calculator and look at 300 and look for our first two positive values since it said non-negative. So let's go back to our calculator, go to y equals. We're going to plug in 300. We need to go to our window to make sure our window is not just crazy. But we go to, well, 10 is actually fine on there. And we need to go up to about, I'm just going to go up to about 900 to make sure I can see everything. We need to be able to see 300. And we need to find our first two non-negative values, which is going to be here and here. Okay, the first one was 2.097. Go ahead and find your second intersection. It's 3.703. 03 is where the calculator, or I'm sorry, the coyotes are endangered. Okay, let's try our next one. Okay, a tsunami is a fast-moving ocean wave caused by an underwater earthquake. The water first goes down, that's important, first goes down from its normal level, then rises an equal number distance above its normal level, then finally returns at its normal level. This is telling you what the water is doing. So it's starting at normal, it drops, it rises at an equal distance above its normal level, and returns back to its normal level. So it's telling you what the water's doing. The period is about 15 minutes. Suppose that the tsunami has an amplitude of 10. It approaches the pier of Honolulu Bay, where the normal depth of the water is 9 meters. Assume the depth of the water varies sinusoidal with time. Okay, then it starts asking all these questions. Down here it says, always draw a graph and write an equation, even the problem does not specifically ask you to do so. Okay, so I'm going to start my graph. So I'm going to start at 9. My amplitude is going to go up 10, so this is going to be 19, and I'm going to go down to -1. So this is where I'm starting. If I'm going to go down first, up, and then end right here. My ending point should be at 15. Okay, so if I do my points, this should go down right here. My first point should go down. I'm just going to make a sketch here. Down. And then my next point should be a middle. Then I should go up. And then my last point should be right here at the middle. And we now know that the period should end at 15. Okay, now remember, I don't really care about all of these points. We can find this middle right here by finding the average between 0 and 15, so that's going to be 7.5. And again, you do not have to find these points unless you're just dying to. I'll go ahead and write those in. That's going to be an average of 3.25, and this is going to be 11.25. Let's go ahead and label our axes. This is going to be time in minutes. And this right here is going to be depth in meters. Okay, let's go ahead and do an equation so we can answer these. There's a couple of ways you can do this. I see this as an inverse sine function. You could go ahead and do a cosine function if you wanted to. So I'm going to write both of these just in case. So this is going to be a depth. Let's do inverse first. Inverse sine first. So this is going to be a shift of 9. Since it's an inverse sine, this is going to be -10. And then my b value. And since I'm starting at 0, you can do t plus or minus 0, or you don't even have to do the 0 at all. So I've got a cycle of 15, so that's going to be 2 pi over 15. And that doesn't reduce. For those of you who want to do cosine, how about we start right here at 11.25, so we can do a positive 1. So this is 2 pi over 15. And this is going to be t minus 11.25. And again, either one of these will work to get your same equation. Okay, now you can go to your calculator, plug either one of these equations in, look in your x in your table, and look at a value of 2. So it says predict the depth of water for 2 minutes after the tsunami reached the pier. So look at an x value of 2. and you should get a Y value of 1.569, and that should be meters. Again, go back to your table, predict the depth of the water at 12 minutes, plug in a 12, and you should get 18.511 meters. Okay, it says according to the model, so we're looking at our picture, what will the minimum depth of the water be? Well, if I'm looking at my picture, the minimum here is a -1. So if I look at my picture, the minimum is -1 meters. But realistically, that can't happen. So realistically, I would say that it would be 0 meters because this is going under the ground. So, but realistic, it would be 0 meters. For how long will there be no water on the pier? So if there's no water on the pier right here, this is the pier, I would set my Y2 of 0 and find my intersection. So Y2, I'm looking at my first two positive values. Right here, let's do this one. My first positive value is going to be 2.673. My second positive value is going to be 4.327. It says for how long, so we're going to have to subtract these two values. So my answer is going to be 2.154 minutes. Okay, if you have any questions, please bring them to class.